We're now going to take a look at material mats and camera projection with photometric atmospheres, especially working with 8-bit images. What I'm going to do is just add in a standard terrain, and we're going to set up a camera projection of a texture map on it. So what I'm going to do is reset the material for the terrain, right-click, reset in the aspect tab, and go to edit material. Switch this over to a mapped picture, and then load in, and I'm going to load in one of my rock textures from the Seamless Rock collection. I'm not going to load it in as a sequence. Right now it just has the standard tiling on it, but what we want to do is assign it to camera projection. So we're going to edit the function, and we're going to set this up now so that it works with camera projection, which means we need to change this from a projected texture map to a texture map. And we need to change the UV coordinates, which we can't just go in and select a different input. So what we need to do is add in an input, right-click, go to camera projection, select our main camera, and our aspect ratio we're going to set to 1.333, and then connect that to the texture map. So now you can see we're projecting on there. And by itself, it works pretty good. But if you're working, let's say, a rendered image where you want to reproject it onto the terrain, or you're taking a projection from a different program that was rendered out, if the exposure doesn't match, and once you set it to a matte material, which if we go up here, and what we have is matte shadow reflection, so only the shadows and reflections are going to show up on here. We can see that the texture is incredibly dark compared to the rest of the scene, and that's because the illumination on here is set to the exposure value, which is 4 higher. But in this case, then we have the rest of the scene being overexposed. If we turn off the natural film response and the auto exposure, we can see the true texture. And when you're saving photometric scenes, and let's say you're saving out the multipass where you've got the diffuse layer, it's going to show up with an exposure value of +4, which is the true exposure value of a photometric scene. So when you take a look at your render output with the exposure set to 0, you're not actually looking at the true output value, because 32-bit images go far beyond what we normally see as white. So if we can see black, then basically once we see white, there's levels way beyond that are included with a 32-bit image. So if we want to use an 8-bit image in this case, or something that has been rendered out at that lower exposure, in order to match it up, we're going to be using the exposure that was designed in one of the other lessons. And we're going to go right-click, color, metanode, and exposure. And we don't need to use the 8-bit version, because we're going to be changing this from an 8-bit image and increasing the exposure level linear for a 32-bit exposure. So we connect our color output, and all we need to do is just increase the exposure by 4. Pretty straightforward. And now we have a proper exposure and a matching for the 8-bit image. What you can also do is go into a post program like Photoshop and increase the exposure by 4, making sure that it's a 32-bit image. So if you have an 8-bit, you got to convert it and then increase the exposure. So this way it keeps with a smaller file size, and you can just do it within view. Now this is only really needed if you're using the matte shadow reflection option. So otherwise we're going to have something way too bright because that is controlled by the diffuse level. And with this high of an exposure, we kind of have like a luminous material without using the luminous option. So what we're also going to take a look at really quick is adjusting and using the exposure with the luminous value to match in with the photometric scene, because that also kind of plays into the reduced exposure value where everything's kind of -4 to the photometric lighting, which is +4. So I'm just going to go back into the function, and we can reduce the exposure to 0, and we'll just keep the matte projection turned on, which we've basically lost our preview because we added the exposure to it. If you want to get that back, there is actually a trick you can do, which is to add in output, and what we need to select is the color blending. And if we don't see the output, then what we can do is add in a color node, color correction, select color blending, our blend color. We connect the parameter is going to be the texture map. And we're going to set it to color mask, blending ratio to 1. And actually, it looks like what I need to do is set the input to our exposure, the blend color, to the texture map, and then connect the color output to the output. Let's see if that brings that back. And it looks like we lost it. So I could just delete the exposure if needed. And it looks like some changes have been made. But typically, what you get is a color blending option. I'm just going to switch this back to matte picture, with this, which is this color blend. And if we blend it with the color, we can set those options in the function as the color blend right here. And then we can use everything we just set up, but using the blend color as the texture map and just giving ourselves an OpenGL preview. But that's really not that important. So what I'm going to do is go over to the luminous value here. And in View 2014, this high of a luminous value wasn't really bright enough. In this case, it looks pretty bright, but if you need to go beyond it, what you can do is just extract the luminous value. And then the exposure is set up for color. And if we disconnect this parameter, what we can do is create a modified version of the exposure where we still have the power and all this, but we can change the multiply by. And then instead of using a color, we can change that to numeric. So we could add an input, a double input, which is going to be numeric, and then change our output to a double output, delete the color, connect those, and because I didn't disconnect that, our constant color is showing up in there, but instead we'll just use the double output, connect that to the luminous, and then what we can do is adjust the exposure. And I just want to make sure, delete that constant color. If it lets me, it looks like that input is not being deleted, but that's okay. So if we need to go beyond the luminous value, we can use the exposure on there as well, just by converting it to numeric, which means we can also adjust the exposure of other things as well. We could use the diffuse in order to create a photometric material. So there's really ways of creating a photometric material, which is pretty cool. Really only useful if you're working with really bright scenes or you need to create your own custom photometric lighting separate from, say, what the sunlight is producing. And I also want to note really quick, we're going to go into Browse Previous Renders, and I'm just going to use a render from a different lesson, which is a photometric render. Now, if we were to save this out as a 32-bit image, because we're working with a photometric exposure, what we want to make sure we do is if we're just saving out from the render browser, render display here, we want to make sure we set the exposure to 4 before we save it as a 32-bit image. I like to use the EXR format, PIS-based wavelet. Because if you don't do this, you're going to lose a ton of color information. So even though it's white, once you bring it into post, you can reduce the exposure, but you don't want to lose those different levels of exposure, which you will if you save it as an exposure of 0.